are two components in wetland construction: technological and natural. What's the role of engineers? Engineers calculate a volume of wetland, choose the appropriate materials and build the skeleton, which involves the hydro insulation and thermal insulation if necessary. Moreover, the engineers calculate…
Excuse me, Ms. Doolittle, but you have missed one point about the wetland skeleton. First of all, engineers have to determine the depth of the groundwater. For what purpose, Betsy?
Oh, I'm sorry, sir. Let me start from the beginning.
Go ahead.
Certainly. At first, engineers determine the depth of groundwater.
If the groundwater is deep enough, a subsurface flow constructed wetland built. If the groundwaters are shallow, the wetland bed is constructed above the surface. Then engineers choose the materials and build the skeleton equipped with hydro insulation and thermal insulation if necessary. Engineers must also calculate the hydraulics, which include the placement of inlet and outlet pipes, the mixing chambers, the installation of monitoring wells, gate valves and dams. Besides that, engineers construct a system of preliminary treatment, which includes screens, grid chambers and settling tanks. And finally, engineers install various devices for aeration, for creating and maintaining water reuse and water level adjustment. Here it should be noted that, first, the technical components of wetland construction are very simple and user-friendly. Second, nowadays there are so many engineering solutions and so much technical know-how that it's possible for constructed wetlands to operate effectively under all climate and weather conditions.
Very good, Ms. Doolittle. However, what about biology? It sounds like you're saying we can't do without it?
Professor Higgins, if you let me finish, I will tell you about the biological component.
Of course, Ms. Doolittle.
First of all, biologists determine the type of substrate for the constructed wetlands: gravel, sand, soil as sorbents of the pollutants and as a base for rooting the plants. As you know, there are many varieties of gravel, sand and soil, but biologists choose the variety that is most suitable for this structure of the wetland in a particular landscape and in certain climatic conditions. In addition, biologists choose specific water-resisting plants as well as the method and density of their planting and dispersal in reconstructed wetland. In addition to their other important properties, these plants should have highly branched root system and, at the same time, adapt well to the wetland ecosystem. Then, biologists colonize the constructed wetland with useful hydrobiota, which develops trophic chains contributing to the water treatment. And finally, biologists design constructed wetlands as a part of the landscape. It means they take factors into consideration such as animal-bird migration and biogeochemical flows within an ecosystem. Professor, have I covered the role of biologists in full? I didn't mean to discredit their work.
Insofar as biologists, everything seems all right. But I see that it's you who is a bit upset. I hope you're willing to answer a follow-up question. Why is it that it is biologists who determine the substrate in the constructed wetland? Why not the engineers who seem to be dealing with the types and sizes of the gravel? Maybe they have confused their roles?
That's a trick question, sir. Only biologists can determine the type of substrate and its modifications for microbial communities that form on the surface of the constructed wetland substrate that will clean wastewater most effectively.
Betsy, I was sure you wouldn't fall for it. I only asked that question to draw your attention to engineer-biologist partnership. Now we can proceed to our main topic.
Okay.
If you don't mind, I will come out to the board to outline the main points to consider if we want to design and construct a wetland.
Sure, Professor, I'm ready.
We know of 4 types of constructed wetlands. However, it should be noted that each of these types had many modifications and that each modification is a product of a joint creative work of both engineers and biologists, both professionals taking part in adapting of the basic type of the wetland to a given climate and landscape patterns and to biochemical composition of the influence. Today, wetland designers are like inventors. Now, could you please go over the 4 basic types of constructed wetlands?
Surface flow constructed wetlands, horizontal subsurface flow constructed wetlands, vertical subsurface flow constructed wetlands, and hybrid constructed wetlands, which combine features of the first 3 types.
That's what we will go over right now. We are going to consider examples of constructed wetland modifications for each type, one by one. First, the surface flow constructed wetland. Ms. Doolittle, could you please remind me of the basic characteristic of this construction?
First, wastewater filtration is performed by plants and not by gravel. Second, they have a dense vegetation to minimize the sunlight on the constructed wetland surface.
Why?
Because sunlight encourages the development of microalgae, which increases wastewater pollution by suspended solids. Third, it's recommended to populate the constructed wetlands with fish, which helps to decrease the development of mosquito larvae.
Correct. From the multitude of variations of this type of constructed wetland, I have selected 5. Modification 1. Wetland construction has built-in fountains. The fountains are activated periodically to increase the aeration of the wastewater. Modification 2. A constructed wetland includes areas of various depth. Thus, there is an alternation of aerobic and anaerobic zones. Modification 3. These constructed wetlands don't have to be rectangular. They can take any form to be perfectly landscaped. Modification 4. The stream flow of a small river is put through this constructed wetland to return treated wastewater back into the river. Modification 5. The constructed wetland is located around the perimeter of a swimming pool. The water is pumped through the wetland so that treated wastewater returns into the pool.
That's amazing!
Indeed, Betsy. However, I have a question for you. Is it possible to treat airport wastewater using any modification of this constructed wetland type?
I think so. This type of constructed wetland can cope with domestic and storm wastewaters.
Of course it can, but this type of constructed wetland will attract a huge number of birds. Therefore, this method is not suitable for airports.
Oh, that's a shame.
Not an issue. There are other types of constructed wetlands that are suitable for this problem. Could you please describe a horizontal subsurface flow constructed wetland?
This type of constructed wetland has 4 main features. First, its substrate works both as a filtering sorbent and a matrix for biofilms. Second, the substrate can be used as biochemical treatment agent, for example, to remove phosphorus. Third, influents are supplied uniformly throughout wetland volume. And fourth, there is a preliminary mechanical treatment mechanism to protect constructed wetlands from clogging by waste and sand.
You're right, as always. Now let me draw your attention to 3 modifications of the horizontal subsurface flow constructed wetland. Modification 1. Gravel of greater size is put at the inlet at smaller gravel is used as the main substrate. This helps to slow down the clogging process of the constructed wetland. Modification 2. If a wetland construction is to have width of more than 15 meters, influents are divided into 2 or more venues separated by baffles. Modification 3. Sometimes specific industrial substrate materials are used for intense phosphorus removal instead of gravel. For example, calcite alumina, which has a high sorption capacity. And of course, I have prepared a question for you, Ms. Doolittle. Please, can you explain why a constructed wetland's length considerably exceeds its width.
Because the key feature in subsurface flow constructed wetland is that the longer it is, the more microbiological successions develop on the water's path during wastewater treatment. Every succession that's a spatial change of biocenosis stimulates treatment. Professor, I hope this time I haven't made any mistakes.
Of course you haven't. Let's move on to the third type of constructed wetland. What are its characteristics?
Vertical subsurface flow constructed wetland has three characteristics. First, this type of constructed wetland treats wastewater without any technical devices for the pre-treatment from sand and silt particles. Second, this type of constructed wetland is the most multi-layered. The top layer is soil, sand lies below it, and bottom layer contains gravel of different sizes. Third, during treatment, a hydromorphic layer of soil becomes thicker as it grows upward.
Right, let's consider three modifications of this constructed wetland. Modification 1. The influent is supplied through the pipes from above and is further distributed uniformly throughout the whole of the constructed wetland surface. Modification 2. The influent wastewater is apportioned in set intervals. Modification 3. The top layer of constructed wetland, which contains hydromorphic soil, gets populated by earthworms, which convert detritus into high-quality organic fertilizer. Thus, the influent receives effective treatment and the obtained fertilizer can be successfully applied in agriculture. Betsy, I have another question for you. Why do some modifications of vertical subsurface flow constructed wetlands use the technology of reciprocating water level change?
The reciprocating motion of water creates alternating aerobic and anaerobic conditions in the constructed wetland. This creates a higher biodiversity of microorganisms, which allows the wetland to treat wastewater more efficiently and in a smaller volume per inhabitant.
Absolutely right. Let's proceed to the fourth type of constructed wetlands, the hybrid constructed wetland. We can skip its main features because
Its main feature is the fact that it's hybrid, which enhances the functional benefits of each constructed wetland, combined into a system while minimizing their drawbacks.
Right. Therefore, numerous versions of hybrid systems are possible from the modifications of these constructed wetland types. There are three modifications to consider. The first hybrid is the most common. Vertical and horizontal subsurface flow constructed wetlands are connected so that the vertical one receives the incoming wastewater, and then its effluent is treated by the horizontal one. What is the benefit of this connection?
This hybrid minimizes the risk of clogging as suspended materials are effectively removed in the vertical construction.
Right. The second hybrid. Two vertical subsurface flow constructed wetlands are connected in parallel. As one constructed wetland is getting supplied with influent, the other remains empty. After a set period of time, the second constructed wetland is filled with wastewater, as the first releases treated water. Then, the first constructed wetland is filled in once again, while clean water is released from the second wetland. This procedure repeats many times. Betsy, what is the logic here?
This technology alternately creates aerobic and anaerobic conditions in each constructed wetland, which results in effective nitrogen removal.
Exactly. The third hybrid. Constructed wetlands of the first, second and third type are connected in a row. For what purpose, Miss Doolittle?
During rainy season, this kind of system can protect both of the subsurface flow constructed wetlands from overflowing. Excess water is redirected through a bypass pipe into the surface flow constructed wetland, which can withstand an extra hydraulic load. By the way, Professor, you omitted the bypass pipe. Did you expect me to forget again?
No, no, Miss Doolittle, quite the opposite. I was sure you would catch that mistake. You did well. We have now covered the wetland construction section in full.
A very important section, sir.
I agree. Moreover, we have successfully completed our special academic course. To be more precise, its basic part.
Thank you, Professor. It was very interesting and instructive.
Thank you. However, it's too early to celebrate. We also have to study bacterial communities that accelerates wastewater treatment. Besides, we have to adjust the constructed wetland types and their modifications to various climates ranging from the Sahara Desert to the North Pole. Moreover, we, as wastewater treatment specialists, have to...
Sir, I hope that not for today, because I'm in rush to get to the theater. Excuse me, Professor.
Well, what play are you going to?
Pygmalion by Bernard Shaw. I want to form my own opinion on that play.
I told you the play was mediocre and the acting as well.
I remember, but we don't always agree.